So these are the two types of problems, and we're going to continue seeing these again today, except we're going to use some different trig functions today. But obviously the difference between these two is this one is when x is on bottom, this one is when x is on top, okay? And so that's why I highly encourage you to write these out. A lot of people try to do the work without writing it out, and then they don't know where x should be. And because sometimes we multiply, sometimes we divide, we're going to add some other problems to the mix as we go. Sometimes we're going to use different trig functions as we're going to get into today. So write out the equation, okay? It doesn't take that much time. The angle measure always goes with the trig function. Yesterday was only tangent, okay? What was the trick here yesterday that we talked about? What's the first thing we should do on this problem? Yeah, we're gonna trade places here. So it is gonna be a division problem. We're gonna trade places with the x and the tan 28. Because if I multiplied by x and then divided by tan 28, it would really just be x equals 13 over tan 28. Okay. What do we get for our answer there if we go to the nearest tenth? Okay. Hey, over here, the x is on top. So we want to get the 22 off the bottom, so we're going to multiply by 22 on both sides. So we're going to do 22 times the tangent of 39, which gets x by itself. So now over here, we're just going to do 22 times tan 39. What do we get for a decimal there? Okay, that's 17.8. It's really key to know how to use your calculator, okay? Make sure you're using the same calculator over and over again, okay? So that you are getting in the practice of being able to go through those and know what's going on, okay? One other thing before we go into the... All right. Today we're going to add the second two trig functions. There's 3 of them total. Yesterday we just did 1 trig function. So pretty straightforward because we only did the 1 of them. These 2 are what we call sine and cosine. Right next to tangent you should see a sin. Looks like sin, but it's really pronounced sine and cosine. And the reason we call it sine is because there's really an E at the end. But on the calculator button on most of them it's just S-I-N. So it looks like sin, but it's really sine and cosine. Are those 2 functions, okay? We still have a right triangle, so that's not going to change. But what is going to change is the legs or the sides that we're going to use here, okay? So if I use sine, it's still sine of the angle, whatever angle we're referring to, and then it's opposite over hypotenuse. Opposite leg over the hypotenuse. So today we are going to use the hypotenuse. Yesterday we didn't use the hypotenuse at all. If I wanted to cosine, we're going to do the adjacent leg over the hypotenuse. Okay, so here's an easy way to remember. We call this SOHCAHTOA, and that's the way we want to pronounce it. Some people say SOHCAHTOA, but I want to pronounce so you know that O is first. SOHCAHTOA will help us to remember, and here's how it works. Sine is opposite over hypotenuse. S-O-H. First letter in each word. Cosine is adjacent over hypotenuse. C-A-H. So S-O-H, C-A-H, and then finally, tangent is what we did yesterday, and we said the tangent is opposite over adjacent, and that is T-O-A. Okay, so from here on out, the rest of this chapter, anytime we are dealing with a trig, we're going to remember SOHCAHTOA, Probably going to write that at the top of our paper every time that we do it, because we're going to have to decide which one of the three trig functions are we using. And I'll show you how we can decide that and how it works. But we got to, first of all, know what relationship goes with what. Okay, and that's where SOHCAHTOA comes in. You're going to hear me say that a lot over the next week or two. Okay. Another quiz lesson. You had a question like this yesterday, and we kind of did one like this yesterday. The one we did yesterday was asking us to do 30, or I think it was 60, and then the big idea is I think asked us to do 30. When you draw the 30, 60, 90 triangle out, I just want you to be aware that like when you draw it, you can draw it a lot of different ways, and we've seen it drawn a lot of different ways. The short side is always opposite the 30, okay? So K is always opposite 30. So here, there, on this one, the 30 is up here, so my K is down here. So when you draw it, just make sure that that short leg is across from the 30. K radical 3 is across from the 60 in both scenarios, okay? And then obviously the hypotenuse is your 2K. And there was one on Big Ideas yesterday that asked you to find the tangent of 30. On our notes, we did the tangent of 60. This one asked us to do the tangent of 30. And what we said was we could plug in whatever number we want for K in either one of these triangles. You don't have to draw both. But what easy number did we use yesterday to plug in for K? Yeah, just plug in 1. And you can use whatever number you want, but I think 1 is the easy one here. So this would be 1, this would be 2, and this would be 1 radical 3. Okay? Now here's the problem with the one on Big Ideas. It was a little bit tricky maybe, but we've seen it before. If I did from the 30-degree angle, tangent is opposite over adjacent, right? Here's my 30. This is opposite, this is adjacent. Yesterday we didn't use the hypotenuse at all. So this is 1 over 1 radical 3, which is really just radical 3. The question was asking us to write it as an exact value. Can I leave my answer as 1 over radical 3? No. Because what do we have to do? We can't leave our answer like this because what's wrong here? Why can't I just type that into Big Ideas and stop right there?
Because radicals are on the bottom.
Radicals on the bottom. We can't ever leave a radical on the bottom, okay? And to get rid of the radical off the bottom, what do we have to do? Multiply by that radical, okay? So that kind of went back a little bit to the last chapter. And then that would give us radical 3 over 3, okay? So I had a couple people ask me about that problem from yesterday. So I wanted to kind of make sure we understood what was going on there. And we're going to see that a little bit as we go through. So definitely something I wanted to be able to talk about. Okay, questions on that? The question that some people were having yesterday was, towards the end of the lesson yesterday, we were solving for x. We were trying to find the missing side. And so then they got a little bit confused when they started Big Ideas, and they were like, how do I solve this? Well, on this one, we're not solving anything because we already know all three sides. There's nothing to solve for, right? They are just asking us, what are these 4 ratios, okay? And we kind of talked about this at the beginning of yesterday's lesson too. If I just ask you, what is the sine of S or the sine of R, and then we're also going to do the cosine of S and the cosine of R. Okay, so first of all, S. We're going to use angle S as our angle of reference. Once again, we will never ever go from the 90-degree angle. We're going to go from one of the 2 acute angles. So here I'm going from S, okay? If I go from S, sine is opposite over hypotenuse. So opposite of S would be 63. And then on bottom is the hypotenuse, which is 65. Okay? The one side that will never change is the hypotenuse. 65 is always the longest side, so it's always the hypotenuse, okay? The other two will change based on which angle we're referring to. So on this one here, if I did the cosine of S, the cosine of S is going to be the adjacent leg over the hypotenuse. Adjacent is next to it. So that would be 16 over 65. The one thing that will stay the same on both sine and cosine is the bottom will always be the hypotenuse. Okay, the hypotenuse always goes on bottom. So on this one, I know that 65 goes on bottom, and on this one, I know that 65 goes on bottom. But now if I go from angle R, okay, so here's angle R. What side would be opposite of angle R? Okay, be 16, right? It's the one that does not touch it. Opposite is across from it, opposite is away from it. 16 is the one side that does not touch angle R. So opposite and then if I go from the cosine of R, this would be adjacent, and then hypotenuse is still 65. Okay, so here's the one thing that I want you to kind of draw the relationship between. The cosine of R and the sine of S will always be the same thing. The sine of R and the cosine of S will always be the same thing. Those two will always be the same. Okay? It's the same ratio, it's the same fraction. Now, this is also asking me to write the decimal rounded to 4 decimal places. So what is 63 divided by 65? It's going to have a lot of the same instructions as yesterday. 63, just take 63 divided by 65. You don't have to hit cosine in your calculator at all. What's that give me? Okay. And if we go to 4 decimal places? 92. Okay. And that would be the same as the sine of S. I don't have a lot of room to put 0.9692, but we know those would be the same. And if I did 16 divided by 65, what's my decimal there? Okay, 6, how much?
2, 4, 6, 1.
1. Okay, what's next to the 1? Is it?
2. Make it a 2.
Okay, all right. Okay, so those would be our decimals. Okay, I'm not going to do both D and F on this next one. I'm just going to pick one. So let's do the sine of D and the cosine of D. So if I go to angle D, sine is SOH, opposite over hypotenuse. So what would be opposite of angle D? 7. The hypotenuse is the long side, so that's 25. Okay, cosine of angle D, so we're still going to D. Cosine would be the side next to it, which is 24. And the hypotenuse is 25. Okay, so if it asks you to write a ratio, notice here we're not putting this into our calculator. Okay, we're not typing in sine or cosine or anything like that. We are simply just writing a ratio. This is the ratio that represents that trig function. Okay, the only time we really do use our calculator here is if we need to take 7 divided by 25 and 24 divided by 25. And for whatever reason, Big Ideas is going to ask us to go to 4 decimal places. So it's the same thing we talked about yesterday. If I do 7 divided by 25, it's going to be 0.28. And that's what your calculator shows. But we're going to go out to 4 decimal places. So we got to add 2 more decimal places to the end, which means I add 2 zeros to the end. Okay, if I do 24 over 25, then that would be 0.96. And once again, we got to add 2 zeros to the end. So just be careful about what they're asking you to round to. It seems like, and I might be wrong on this, but it seems like if you stop it right here, it might count it wrong because it's not really 4 decimal places. Did any of you guys try that yesterday and just put in 0.96?
I think I might have.
And did it count it right or not?
I think it counted it wrong.
Wrong. Okay, and that's what I think. I could be wrong, but that's what I remember is that it does count it wrong if you don't go out to those 4 decimal places. So that's why we talk about it there. Like on a quiz or a test, if I was going to give this to you and you put 0.96, I'm probably not going to count it wrong. I'm probably not going to ask you to go to 4 decimal places because it stops at 0.96. Okay, so, but if you had to go to 4 decimal places, that's what it would look like. Okay, real quick here, I'm going to draw this triangle, and I think this helps to explain what's going on here so you understand what we're doing. Okay, the sine of 56 is equal to the cosine of something else, okay? So I'm going to put a 56-degree angle in this triangle. We don't know any side lengths or anything like that. But let's label it like we did with the Pythagorean theorem. Let's just label it A, B, and C, okay? What would be the third angle in this triangle? $34, okay? Triangle has to add up to be 180. So my missing angle has to be 34. Okay, they're asking us, we're going to do the sine of 56 to start off with. The sine of 56 is opposite over hypotenuse. So I don't have numbers here, I just have letters, which would be B over C. The sine of 56 is going to be the same as what? What else would give me B over C? Well, if I go from 34 degrees, this would be the adjacent side. This would be the hypotenuse, right? So that would be the cosine of the other acute angle. So the sine of 56 and the cosine of 34 are both the same ratio. So those two are equal to one another. Okay, now, do I really have to draw the picture? Not necessarily, okay? I think that helps to kind of understand relationships and what's going on. But if we do it again here, and I said the cosine of 23 degrees is going to be equal to the sine, what angle would I use if I don't draw a picture? What do you? Yeah, 90 plus 23, and then subtract it from 180 because we need 180 in the triangle, right? Or because we already got 90, I know 180 minus 90 is 90, so then I could just take 90 minus 23, and what's that leave us? 67.
No one wants to say it.
Huh?
I said no one wants to say it.
No one wants to say it. Afraid they're going to be wrong, maybe, right? Cosine of 23 and the sine of 67. Those two are what we call complements of one another. So that's what it's talking about right here. The sine and cosine of complementary angles. We've talked about complementary, right? Complementary means two angles that add up to be 90. These two angles add up to be 90. So the cosine of this guy is the same as the sine of this guy. I could also say the sine of this guy is the same as the cosine of this guy. Okay? So they have the opposite relationship there, but they're complements of one another. Okay, the next thing we're going to look at is similar to what we did yesterday, okay? Except now we're looking at different sides and we're doing a little bit different work here. So we're going to go the sine of 26 equals 26 is the angle I know. So that's the angle I'm going to use, okay? And let's say that we want to find x first. It doesn't really matter which one we find first. But if I'm going to go from the 26-degree angle, I know that's what's going to go right here, okay? And I used sine because where is x from 26? It's opposite, right? This is my opposite side. This is my hypotenuse. Sine is opposite over hypotenuse. That's how we decide what goes on top and what goes on bottom. Opposite over hypotenuse. Opposite goes on top, hypotenuse goes on bottom. We saw problems like this yesterday. When x is on top, what are we going to do to solve this? How am I going to get x by itself? Yeah, just multiply by 14, okay? Very similar solving to yesterday. The only difference is we're using sine instead of tangent, okay? Just use that different button in your calculator. So now let's try plugging this one in. Okay, what do we get? Okay, 6.1. Rounding it to the nearest tenth, one decimal place. Okay, now if I wanted to find y is the adjacent side to 26, because it's right next to it, it touches it, okay? Adjacent touches it, opposite is across from it. So this time, it's CAH, so it's cosine of 26 equals opposite over hypotenuse. And once again, the solving of it is exactly the same thing. The only difference is we're going to use cosine instead of sine. But we punch it into the calculator exactly the same way. We're just using a different trig function to get there. I always use the approximate symbols because most of these answers are not going to be exact. They're going to be rounded decimal answers. And so we're just saying it's approximately 6.1, or for y, 12.6. Is that right? Okay. Okay. Anybody need help with the calculator? Pretty similar to yesterday. A little bit different. Okay. Let's go down here. From 65 degrees, what side would we call U? Hi there. Thank you. See ya. Have a good day. From 65 degrees, what would we call U? What is it? Opposite, adjacent, or hypotenuse? Adjacent, because it's touching it, right? And what you might want to do is, you might just want to label the hypotenuse immediately, okay? Because it's across from the 90. We don't necessarily know it's the longest side, even though hypotenuse is always the longest side, because we don't know what the length of U and T are. But we know the hypotenuse is always across from the 90. So you might want to label that one first. U is adjacent to 65. This is opposite of 65. 65 is what we call our angle of reference. That's the angle that we are looking from. Because right now we don't have this one labeled. I could find it, right? But we don't know it, so I'm not going to use it. I'm just going to use the 65. And so now as I look at it, it really doesn't matter which one we solve for first. So let's say we solve for U first. If I solve for U first, from 65, this would be adjacent, and this would be hypotenuse. Since this is fairly new, if it was me, you probably want to practice writing this down. We're going to use this over and over and over again, a lot over the next week or so, okay? And so if I have A and H is cosine. So we're going to use the cosine function here. So I'm going to go cosine of the angle equals adjacent over hypotenuse. Okay, and then if I wanted to find T from 65, this is opposite, and hypotenuse. O and H is sine. So when I write this one out, I'm going to do the sine of 65 equals t over 8. And those are very similar to what we just did on the last one. I'm going to do one more here at the bottom with you. I'm going to show you a little bit different kind of problem. Okay, so T, I think we get about 7.3. And what about U? What do we get for U? 3.4. Okay, if we're round to the nearest 10. All right, you got some space there at the bottom of your page. Draw a triangle out, a right triangle. Looks just like the last one we had. Right triangle. Okay, this is where it gets fun, right? We have one side given to us, 11. I can't do the Pythagorean theorem because I only have one side. I can't do a special triangle because I have a 41-degree angle, which isn't really special, okay? But because it's a right triangle, I can do trig. So trig's our go-to here. We can't do any other things that we've talked about in chapter 9. I want to find x and y. And it really doesn't matter which one you find first. So let's start with x, okay? Or let's just label all three sides. What are we going to call y? The hypotenuse, right? How do we recognize the hypotenuse? It's across from the 90, okay? That's the easy one, okay? The other two will depend on which angle I'm talking about. Am I going to talk about this one or this one? Well, since I don't know this guy down here, I'm using the 41-degree angle, right? So from 41, what would we call x? Adjacent. Adjacent is next to, which means opposite is across. Okay? Your three sides are either going to be opposite, adjacent, or hypotenuse. And it's always in reference to the angle that we are going from. Okay? Never the 90. Always the acute angle. So from 41, let's say we find x first. I'm just going to cover, well, I can't cover that guy up. I'm going to cover the hypotenuse up because I don't know the hypotenuse. Okay, so from 41, the two sides that I'm going to use here are the side I'm trying to find and the side I already know, right? So from 41, I'm going to use the adjacent and I'm going to use the opposite side. So O and A. As I look at SOHCAHTOA here, O and A tells me tangent. So this means tangent could be in play here, right? That's what we used yesterday. Just because we used it yesterday doesn't mean we can't use it today. So we're going to say the tangent of the angle. And then when you decide what goes on top and what goes on bottom, whatever letter comes first goes on top, whatever letter comes second goes on bottom. So opposite over adjacent. Opposite is 11. Adjacent is x. That's why it's so critical that we write these equations out. Trying to do it without writing the equations out can be difficult at times. Okay? Because x is on bottom, how are we going to type this into our calculator? Same thing we did yesterday. 11 divided by tangent 41. We're going to flip-flop the tan 41 and the x, and we're going to take 11 divided by tan 41. $12.7? Okay. Okay, now let's find y. I would go with the information that you're given, so I wouldn't use x to find y. Okay, I'm going to cover it up. From 41, 11 is opposite, hypotenuse is my y, so we have O and we have H. When I use O and H, I go back up here to SOHCAHTOA, O and H, opposite and hypotenuse, uses S, the sine function. Okay, that's how we decide which of the three functions we're using. So we're going to write sine of 41, we use the same angle measure, opposite over hypotenuse. The equation looks exactly the same, but the big difference is we have a different trig function. Okay? We have to use the correct trig function in order to get the right side length. And same thing, we're going to flip-flop the y and the sine 41, and we would end up getting, what's our decimal there? 16.8. Okay. Any questions on how to decide which trig function or calculator? You guys feel like you get the hang of it, Leah?